In this example, we have a sports store has a net revenue of $100 on every pair of downhill skis sold and $120 on every snowboard sold. The manager's goal is to have a net revenue of more than $600 a day from the sales of these two items. What combinations of ski and snowboard sales will meet or exceed this daily sales goal? Choose two combinations that make sense and explain your choices. So first of all, we need to set up an inequality that would fit for this. We have, if we say that the number of skis is represented by X, and Y is the number of snowboards. So that's how many are sold each day. For each pair of skis that are sold, there is $100 made, and for each snowboard sold, there's $120. We want to exceed $600 a day. So we want to be more than 600. We have to think about what kind of values we could possibly have. Can we have decimal values here? No, we can't sell part of a ski or part of a snowboard. Could we have negative answers? And again, the answer would be no, you can't sell -5 pairs of skis. Could you include the value of 0? Yes, we could sell 0 skis and only snowboards, or vice versa. So what we are dealing with here is we are dealing with whole numbers. So X can be a whole number, Y could be a whole number. So very important when we get to the solution. We are dealing with discrete data. So what we can do is we can graph this value here. Now we could use the intercept method or we could use slope-intercept form. Because in previous lesson we reviewed the intercept method, here I will review slope-intercept form. So we want to get the y by itself. So we are going to subtract 100x from both sides. So we will have minus 100x plus 600. And then we are going to divide by 120. And we get y greater than negative 5 over 6x plus 5. So what we can do now is we can graph this. We have to remember we are dealing with discrete data and there is no equal sign. So we are going to be drawing a dashed line. We start with the y-intercept, which is going to be 5. And then we have a rise of -5 and a run of 6. So we're going to go down 5 and to the right 6. And we are going to join these using a dashed line. So now what we need to determine is whether or not we are going to shade values above or below this line. Now the other thing to keep in mind, at this point, we are actually only dealing with the values in the first quadrant. Because we are dealing with whole numbers, we do not have to extend outside of this region. So we are only going to consider the values that are in the first quadrant. So we'll check a test point here. We can check 0, 0 because both of those are whole numbers and they are still in the region that we need to consider. So we can try plugging 0 into both of these values. We get 0 greater than 5. That is not a true statement, so that tells me we are not going to be shading below the line. We are going to be shading above. Because it is discrete data, we are going to be stippling our region. We only need to stipple the parts in the first quadrant. So we would stipple all of these values. And again, I'm not going to stipple all of them. Hopefully you get an idea. All of those points there would be stippled. So now, the question said, choose two combinations that make sense and explain your choices. So what we need to do is we need to find 2 points that are stippled and see if they work. So let's pick this point right here. This is at 1, 2, 3, 4, and 3. And let's substitute those values in. So y will be 3, x will be 4 plus 5. What we will have here is 3 greater than. We will end up with 20 divided by 6, so negative 3.33 plus 5. So what we will have now is 3 greater than 1.67. That is a true statement. So we know it is possible to sell 4 pairs of skis and 3 snowboards, and we will make more than $600. We could choose another value. Let's choose this one right here. So that is at 6 and 2. So we are going to substitute 6 in to the x spot and 2 in to the y spot. All right. So when we calculate this, we get 2 greater than negative 5 plus 5, which is 2 greater than 0. That is a true statement. So we could also have sold a combination of 6 skis and 2 snowboards. Now really, if you look in this combination, in this stippled area, you're going to get a large number of values. You may in fact get 1,000 and 1,000. But is that reasonable? Are you going to sell 1,000 pairs of skis and 1,000 snowboards in one day? Not likely. So you have to consider reasonableness to the questions as well.